A boat in the sea is an ideal target for all sorts of marine organisms looking for somewhere to settle. After just a few months in the water, the hull of a boat could look like this.
So here we start to see typical shell fouling. We've got sea squirts. This is another solitary animal fouling species, and tube worms and barnacles. You can imagine if you're going along in a boat with all this on the outside of it, then it slows down the vessel. Yep. And if you want to go faster, then you have to use more fuel. So that's not very good, both in terms of economically and environmentally. You're burning a lot more fuel.
Biofouling is a huge problem. A heavily fouled ship may use up to 40% more fuel just to maintain speed. It's estimated that the specialised paints, which reduce fouling, save ship owners €20 billion a year and prevent nearly 400 million tonnes of greenhouse gases from being released into the atmosphere. The aim today is to develop a new generation of non-toxic paints which will be more efficient. That's the challenge that has been taken up by a major European research project known as Ambio.
Well, the purpose of the project is to find a range of novel nanotechnology-based solutions to coatings that control marine fouling, but without the use of biocides. And biocides are compounds which kill organisms. The purpose of Ambio is to find coatings that work by reducing the adhesion strength of organisms so that they come off in the water, but without killing them. That adhesion takes place through the use of adhesive proteins. These proteins have components in them which are effectively nanoscale. And so, if you have a nanoscale problem, you need to look for nano-sized solutions.
One of the experts in nanotechnology working with the project is Professor Galli. He has come up with a formula for a new nanostructure coating which is showing considerable promise.
Well, it's strange enough. It is kind of sticky, so which is kind of contradiction that our material should be rather to be slippery, so that the organisms that sticks on here, but then they move around and they are dislodged simply by brushing or by gently touching them. And this is because this is amphiphilic and nano-patterned.
The amphiphilic molecules in the coating have a curious relationship with water. Part of the molecule is hydrophilic, so it attracts water molecules. Part is hydrophobic and pushes them away. This amphiphilic combination produces a nanoscale pattern which barnacles and algae find extremely difficult to stick to. Tests of these coatings in the laboratory have been very encouraging.
What we found is they perform very well. They effectively like non-stick surfaces, so if you apply pressure to them, the barnacles just slip off. So we were very pleased about the performance in what is a relatively short time frame that the Ambio program had.
Today, the coating has moved out of the laboratory and into the hands of another partner of the Ambio program, International Paint. They have been testing its performance in real conditions in the sea near Plymouth.
This is an example of an Ambio type product. When a vessel starts to move, the water rushes past the panel and removes the fouling, so the fouling can just slide off the panel. I can demonstrate, for example, how easy it is to remove the fouling from these coatings. So you can see that if the vessel's moving, then the fouling can fall off that coating. These barnacles just fall off. So you can see the barnacle's still alive actually, but it can't stick to the coating because of the properties of the coating.
It would take several years of testing before the coating can become a commercial product. But Ambio is already a prime example of the way European nanotechnology research can provide novel solutions which are both effective and safe for the environment.